Hello everyone, today we're going to do an example question on mechanism. Okay, so let's start reading this question. So it's give you a reaction, tells you that's your overall reaction. Okay, so you know overall reaction, you only can determine the rate order, the rate law for this reaction by doing experiment. Okay, and then you have proposed mechanism. Okay, so with the mechanism, you know these two equations representing the elementary steps. Okay, and then with this example question giving us example as the mechanism with a fast initial step. Okay, and then this is gonna take a few steps to get to the rate law for this reaction. Okay, so now let's start doing that. Okay, so remember we said for elementary step, you actually can write out the rate law just based on the equation itself. Okay, so now let's start to do that. So for the first step, when you have this reaction, okay, so when you have A2, okay, this double-headed arrow means that's direction is going to reach equilibrium. Okay, so when it's reached equilibrium, the rate going forward and the rate of reverse direction, they equal to each other. That's something you have to understand in order to solve for this question. So now let's have that. So the rate of forward direction will equals to the rate of the reversed direction. Okay, and then we all know how to express the rate of the forward direction. Okay, so let's do that first. Okay, so the rate of the forward direction will equals to, yes, the k, I'm gonna use k1, so I'll just have this. Okay, so k1, k negative 1 to represent the rate constant. Okay, so the forward rate constant will be k1 will times the concentration of the reactant. Okay, and then the rate of the reversed reaction, okay, will be k negative 1 and then a squared, because I have 2a, that coefficients. Okay, so now basically 2a you can see it as a plus a. Okay, and then the concentration times then equals squared. Okay, and then again, since it's a the reaction reaches equilibrium, the rate of forward equals rate reverse. Now we can have this relationship. So k1 times a2 equals to k negative 1 times a squared. Okay, now we have this. Okay, so now let's keep on going. Okay, so now let's look at the second elementary step, which is giving us that a plus b have AB, and this step is slow. Okay, so this step is slow, and then the rate for this reaction, the elementary step, is going to be K2. I'm just assigning any rate constant for this reaction. That's going to be okay. Okay, so that's what we have. Okay, and then again, we already talked about the rate of the slow step. That's gonna be the rate determinant step. Okay, and then that also is gonna equals to the overall reaction rate law. Okay, and then the problem will be if you look at our overall reaction, the reactants is A2 and B. Okay, and then by looking at our slow step rate law, we have A and B. B is fine, but A is not in our overall reaction as a reactant. It's not there. And then what do we call this? You produce in the first step and use it right away, consume it right away. Yeah, this is called the intermediate. Okay, so this is our intermediate. It's not in the reaction. Of course, you cannot use it to express the rate law for it. So that means we have to replace it with A2 probably, because that's one of our reactants. Okay, so we're gonna express this intermediate with the rest of the terms in this relationship. Okay, so we're gonna do that. So we're gonna reorganize this equation. Okay, so that A, the concentration of A, will equals to K1 divided by K negative 1, and then you have A2 concentration. And then in order to have just concentration of A, I need to do a square root of all the other variables. Okay, so now that's what I have, and now I just need to replace the concentration of A with everything else over here. So I'm gonna put that into this relationship. Okay, so now I'm gonna do that real quick. Okay, so that will turns out to be the rate of this reaction equals to K2 times the square root of K1, K negative 1, A2 times the concentration of B. B is not under the roof. Okay, and now let's simplify this. Okay, so you have K2 times square root of K1, K negative 1, and square root of A2 times B. Okay, and then all this over here, they are the rate constant. So now I'm gonna combine all this into a K to represent for the overall reaction. Okay, and then the rest I'll have A2 square root times B. I can also express it as this way. Okay, so they're the same thing, but if you this looks better for you. Okay, so now this will be the overall rate law for our reaction right here, and you derive it. Okay, again, no matter what, at the end of the day you have to do experiments and to see if your proposed mechanism is going to be proven by experimental data. Okay, so this is the end for this video, and this is how you do a mechanism with a fast initial step, how you derive the rate law for the overall reaction. Okay, so thank you for listening.